Hello everyone, this is Vishnu and my concept video for subject DMS is on degree of vertex. So let's get started. So what is a vertex? So vertex, which is also known as nodes. Um, so this vertex is represented. It's basically represented with a circle or a O shape, and with a label or without a label as well, and there would be 0, 1 or more than one edges are nothing but the connections where with the help of these connections we can connect two or more vertex. So graphs are usually made up of these vertex and edges. So coming to isolated vertex, actually there are types of vertex, and a few are isolated vertex, leaf, source, and labeled and unlabeled. So isolated vertex are those vertex which are not connected to the other group of vertex. So if we take an example like this, where there are four vertex and these three are connected, but this vertex is remain is not connected to any of the other vertex, then this can be said as isolated vertex. So leaf vertex. So leaf vertex are those vertex where if we consider a graph like structure like this, where the last nodes or the nodes which doesn't have a child, then we can call it as leaf nodes or leaf vertex. Where in this diagram the examples are this, this, and this vertex, and these three vertex are leaf vertex of this whole uh, graph. So source vertex is nothing but this very top vertex, which is known to be the source vertex, and labeled and unlabeled. So now what we are exactly looking at is an unlabeled vertex or unlabeled graph. We can also say that this is unlabeled graph, and unlabeled vertex is nothing but a single vertex which doesn't have any kind of address or name. So we just left like this. So this is an unlabeled vertex, and a labeled vertex would be with something in it, which I'm denoting it as a vertex. So this a labeled vertex, and the low one is the unlabeled vertex. So moving on, what is a graph? So graphs are nothing but the diagrammatical representation of the data in a 2D space. So let's say number of people who are attended for a party of a particular age. So we can create a data set which is like number of and age. So number of and age. So, mm, so let's say we have 20 members of age 18, 5 members who are age 19, and 10 members whose age is 25. So now we have a table with data where we can consider the uh, number of people as x, or take it in a x-axis, and the age under y-axis, and this is under y-axis. So we can plot a graph where which can say like this is 5 and 19. Let's say the data point is over here, and it's 20 and 18. Let's say the data point is over here, which is -1, 20, and 10, 25. So on x-axis it's going to be 10 and 25. So we took an example of a sample data where this is nothing but the graph. So this is nothing but the graphical representation of the data in 2D space. So the study of this graphs is known to be as graph theory, and this graph theory is one of the oldest studies, since the history has evidence that the theory is originated in the year 1735. So there are two types of graphs which are known. So one is directed, one is undirected. Directed graphs are kind of graphs where those edges are given a direction to them. So this no, the top node is pointing out to this node, and this node to this node, and this top node is connecting to this bottom one. So this is a directed graph, and this graph becomes undirected when there are no such arrow marks which are saying that the data is transferred in such a way. So now this graph became an undirected graph, since there are no directions specified to the vertex. So moving on, what is the degree of a vertex? So degree of vertex is nothing but the number of edges which are connected to that particular vertex. So in the case of an isolated graph or null graph, there are no edges. Null graph is a graph which it just has a single vertex, not even more than one vertex, just a single vertex without any edges to it. So it's a null graph. And isolated graphs are the graphs which are separate from a already from a graph which exists, I mean, with edges and which are interfaced with edges. So those those are known to be as isolated graphs. And vertex with a self loop has an edge of degree 2. So its self pointing loop or self edge would look like something like this, where considered to be as node, and this is a vertex. Actual, sorry, vertex, and this is the edge, and this edge points out to itself. So this is known to be as the uh, self-looping edge. So let's take a problem. Let's say like we have a graph with data points, let's say this is our sample example, and these are connected with edges, where these are undirected edges, as we can see. So for that, and let's consider this as a graph, and so now this is where this the edge which is there at the right, the vertex of the node. This node is known to be as isolated one, and let's consider this node or vertex. So for this vertex, we can say that the degree of this vertex is 2, and degree of this vertex is 2 as well. And coming to this vertex, the degree of vertex is 3, and this vertex it's 2, 2 again, and 2 as well. So this is how a degree of vertex is being figured out or is being found by calculating the number of edges connected to that node or the vertex. So that's it. Thank you.